So hi all. First, thanks for joining this conference here in New York. Has some of you been at HBaseCon in California on spring? Okay, have you attended the same talk in California? I hope not. Okay. Okay, so I'm going to talk about HBase and Spark state of the art, what we have in the different HBase releases. Just one slide about myself. My name is Jean-Marc Spaggiari. I am an Italian name. I'm born in France. I live in Quebec. I work in the US. I'm Canadian. So don't ask me where I am from. I have no idea. My name is Jean-Marc Spaggiari, GMS. Thanks my parents for that. GMS for Java guy is absolutely perfect. I love my name. I'm a principal solution architect for Cloudera, so I work on development, but before that I did some management and some architecture and so on. I am a co-author of architecting HBase applications for O'Reilly. There is a book signing at Strata on Wednesday morning and Wednesday afternoon if you are attending. International, I work from Paris to Los Angeles, so I cover very broad territory. I took 108 flights last year, something like 100 flights this year, so I travel a lot. And HBase contributor, Phoenix contributors, and so on. So let's jump into the topic. This was supposed to be the overview, the agenda of the talk, but I had to remove some slides, so it will not be very stick to that, but close to that. So we will look at where we come from examples, very important examples, improvements, and Spark streaming use case at the end. There is also some slides about DataFrame. Source of demand, so why we did that? Basically, I work on the field at Cloudera, so I'm on customer site every day. And you might know that, but people love Spark because it's efficient, it's very easy to use. You can do Scala, you can do Java, so it's very, very fast. So people were asking to have access to the HBase APIs from Spark. So how do I do a get, a put, a scan, or even all the regular HBase calls, like the bulk loads and everything like we have today in Java world for HBase. Spark streaming also, same thing as Spark. Spark streaming is very popular. It's a keyword. You know, when you say Kafka, Spark streaming, few words like this on your resume, you will get hired. So it's very, very good to have that on your knowledge. So let's see how it has started. So do we have Andrew Patel? I think Andrew did not make it, right? Okay, so Andrew started that some time ago on the Apache side, and he worked on I think it was a separate GitHub to do the Spark work on that, and then a few other guys, very good, jump into that. Sean, John Che, Ted Yu, and Ted Malaska, and Matteo. We might have some of them. Not any of them? Okay, cool. So they took it, they built something very nice, and now it's really a module on the Apache HBase version 2.0. So we have a Spark module, which can do almost everything, and we'll go into that. So we can do normal Spark calls. You can do gets, puts, scans, and I will show you how. We can do Spark streaming, we can do bulk load, and we can do Spark SQL. Some of that is already available in the Apache version 2.0. Some of that is available on the Cloudera CDH version 5.7 with HBase 1.2. There has been some backport. And some of it, I think it's also available on the Hortonworks version 1.6, but I will need Hortonworks to confirm, if they can. So if you want to play with that, you can use the 2.0 version from HBase, which works, or you can use any of the vendors' versions, which are like older versions, but they work also. So that's the magic under the cover. So if you know Spark, the application will run into an executor. And inside of that, you have to do everything. If you don't have your HBase connection, you cannot connect to HBase. You don't have the configuration, you don't have the tables, you have nothing. So the magic was simply to give you access to the connection from the executor. If you are inside your executor, you have your HBase connections, you can do whatever you want. You can get your table, you can do your scan, your put, your get, whatever you want. So this is very simple on the slide. It was a bit more complicated underneath. So how you get a connection on Spark? It's very, very simple. You should be familiar with the 3 first lines, if we don't count the comments. Configuration, you always create a configuration, even today when you do a regular Java application outside of Spark. And then we add the resources if we want to, and then you have the magic line. Just one single line, and you will get an HBase context for Spark where you will be able to do whatever you want. So all the examples will reuse this context, and you will see it's very, very simple to use. So on the HBase context, we have an implementation of almost everything. You should be familiar with that if you are familiar with HBase and Spark. So the for each and map, they come from the Spark world. And then the bulk loads and deletes and so on, they come from the HBase world. So I will go through examples from those functions, and you will see that it's very simple. First one, just quick question here. Is there anyone in the room here which is not familiar with Spark? Okay, perfect. I will hire all of us. First one is if we want to iterate over an RDD. So suppose you have an RDD which is not an HBase RDD, it's just a regular RDD. You have a file or you have a stream coming or whatever you want. And you want to process what is inside this RDD on your partitions, and you want to interact with HBase. The only thing you want to do here is you get a mutator for your table. A mutator is like something where you will give mutations to HBase. Mutations is a modification. Can be a delete, can be a put, can be a, I think it can be an increment also. So you will just iterate over your RDD with a for each loop, and inside of that, you will do whatever you want with your mutator. So you can create a put object and give that to the mutator. You can create an increment object. You can create an append object. And you will put all of that into your mutator, and at the end, you flush and close your mutator. All of that will go to your HBase table. It's very simple. It's very close to what you do on Spark today. The only difference is the first line where you have the HBase connection. Because you have the connection, you can get the table. Because you get the table, you can do whatever you want. Something you don't want to do is do not create your mutator inside of the for each and close it after, because it will be many, many, many small calls to HBase, and you prefer to like buffer them. That's the goal of the mutator. That's the exact same example, but in Java, just to show you that we can do both Scala, the previous slide, or Java. I usually do Java, but for some of the calls, there is only Scala. So just use the one you prefer, and both of them works very well there. It's not more difficult because it's Java. You have the connection on the parameters, and same thing, your while loop to get the mutator, to iterate with the mutator, and then the flush at the end. So very similar. The map. So if you are used to this one, to the for each partition, the map is very similar, just that we return something at the end, but it's the same thing again. Here, what you can do as an example is you get a stream. And what you want to do is you want to enrich this stream. So you get your table, and then on your loop, you will do a lookup on your table. You will enrich your RDD. You will return something which is different, but with more information. Or if you want to perform like puts, you can do the same thing. Anyway, you have a connection, so do what you want. Okay, this one is a bit more complicated. It's a bulk load. Is there anyone in the room familiar with the HBase bulk load? Okay, few of you. So let me explain what it is. HBase works with H files. You might have seen that on the Splice machine talk. They talk about the H files. They are the files where HBase will store everything. So HBase will get the puts in the memory, will buffer that until a certain size. When it's too big, we flush that to disk. When we have too many files, we compact them together to make a bigger one. All of that takes time because we have to go to the memory, to the flush, to the compaction. It takes a lot of time. And sometimes we want to avoid that. So what we want to do is we want to build a file, which is an HBase format, and we will give the file to HBase. Instead of going to all the memory and all the process, we create the files ourselves, and we give the file to HBase. As simple as that. So this is what this method is doing. So basically, we have a RDD, and we will iterate over the RDD to create a bunch of files that we will give to HBase to serve to the client applications. So what we want to do here, we want to process the lines and transform them into a row, which means I need to have my row key, my column family, my column qualifier, and my value. And that's all what is difficult into this method. Everything else which is not highlighted is just simple. I give a staging folder, I give a few functions after to load the files. So here I transform my RDD into an iterator, which is a key family qualifier and a value. And that's my row into HBase. Key, family, qualifier, value is a row. When I'm done with that, I just load the files into HBase, and that's all. So here, I have no interaction with HBase. You see there is But there is a context on the top, but I don't need the connection, because what I do is I create files that I push on HDFS to the HBase folders. I don't need to talk to HBase. We talk to HBase a bit because we need to take the configuration of the column family. Is there compression? Is there like different block size, whatever? So we'll do some lookups, but after that, we don't interact with HBase. So this is very light on the HBase side, and it helps to load a lot of data. This one is a small, do I have? Yes, I do. This one is a small modification compared to the previous one. On HBase, we can do very wide on the columns. If you don't have too many columns, you can do just one row key and all the columns. So you save repeating the row key again and again and again and again. So here we create the row key at the top. We iterate over the qualifier and the values. And at the end, no, I don't have it. At the end, we just give everything with one single row key. So I give one row key and all the columns at once. It's a bit more efficient, but it doesn't work if you have too many columns. So it depends what's your use case. Multiput, so same thing. You should be familiar with Multiput on HBase. It's a Java API where you can do all the puts.
Why doesn't it work when you have too many columns?
Sorry?
Why it doesn't work when you have many columns?
Okay, question is why it doesn't work when you have too many columns on this one? It's because you will keep all of them in memory. Here, we iterate over all the columns to put them on a list. So if you have a table with 1 million columns, they might not fit into your memory. So if they don't fit in memory, you want to flush them automatically with a buffer mutator.
But Spark probably will break it into the
It depends. It might not. Let's say here you get your for loop, and inside of that, you get values that you split into 10 columns. So maybe you will receive 1 million, but on your side, you will create 10 millions. So it depends what you create at the end. The output of that should not be too large. It's just you to know your use case. If you know you are going to have like 10,000 columns at the end, that's fine. Just use this one. But if you think you are going to have 10 million columns, it might be too big.
So you can use some techniques like, introduce some kind of maximum that goes over the maximum and try another.
Yes, yeah. So the comment is you can use some techniques. So you count them. If you reach 10,000, then you emit at the end and you come back or you reiterate or something like that. You can. Honestly, me, when it's too wide, I just prefer to use the previous one. So I don't even have to think about that. This guy will do the same work, just it will repeat the row key each time, but I will not have to worry about the number of columns. Sometimes you know you have just like 5 columns. So fine, go with the next one. If you don't know, you are not sure, just go with that one. So the multiput here, there is a small difference between this guy and the Java API. Here, it's a multiput for the same row. One row, multiple columns, column family, whatever you want. On the Java side, the regular API, not Spark, it's whatever row you want. You can do a multiput with rows which are different. They will go to different region servers. This one here, as you can see, the new put, we have just one record, and then we iterate over the values. So we have just one row key. Bulk put, what's the difference between bulk put and multiput? Oh, yeah, the Java version. Okay, what is this one? Yeah, exactly. It's the same thing, Java version. Bulk delete, same thing. I will not go through this one. It's very simple. It's like you want to iterate over values and you generate deletes, same thing. Okay, so what we have seen in the previous slides is where you iterate over an RDD and you interact with HBase. But what you might want to do is as HBase as an RDD. This is to do that. At the end of this example, you have an RDD, which is backed by an HBase table. So if you want to process a file, do the previous examples. If you want to process an HBase table, do this one. And this one is very simple. And there is a big mistake on this screen, and I hope you will get it. So this is very simple. This is a configuration, so Spark context, Java context, and configuration. This should be pretty simple for everyone. And then the Java context. So just initialization. There is no magic here. We should be used to that. Here, there is a big mistake in this one. Where is it? Which one? No. The set caching. You should put 0 in the set caching. This is a full table scan. I don't want to cache anything here. I will do a full table scan anyway. If I read 10 lines, I will never go back to read them again. I will continue to read my entire table. So why do I cache the lines? It's totally useless. Don't cache your lines. I did this one. I don't even know why I've put 100 here. So this is very similar as what you will do for a MapReduce job. Okay, on the MapReduce job, you will do the exact same thing. Just the last line here, it's Spark. On MapReduce, you will do a job and you will give the scanner. Same thing here. I will do something. I will give the scanner. I can put filters. I can put whatever I want. So the last line is really where I get my RDD. And that's the only thing which is new for you on the Spark world is this last line. Everything else before is exactly as what you will do for a MapReduce job. The only difference here is this last one, where I will say, give me this table as an RDD. And then from that, I can do whatever I want. I can do map. I can do process partitions. You can do whatever you want. It's an RDD from Spark. You will process that as any other RDD. Very simple. But I found it very simple. I tried it. It works well. So I think it's simple. OK. Too much wording in this slide, I think. Basically, it's a lot of improvement, okay, because before that it was more MapReduce. Now we're able to do Spark, which is a big improvement between the two, which is very good. Data locality, performances, partition pruning, and so on, like column pruning. We can push a filter, so it's like MapReduce when you push a filter on the server side, so you don't get that back. So something has been done here. Spark SQL and integrated language query, we will see that after. Native support for Java types, it goes with the previous one. And the two last one, okay. Spark is pretty new on HBase world, new and not new, okay? It has been integrated in version 2.0. It's not in 1.1, 2.3, it's not there. It's not fully done now. There is still some things missing. If you look at the first one, reduce the number of connections. It's someone from AutumnWorks opened that recently. There is too many connections open on the Spark side. There is work to do. The second one, add Java access to Spark bulk load. There is no Java method for the Spark bulk load. There is only a Scala one. So there is still few things missing here and there. If you find something missing, open a Jira, and we'll find someone to fix it. OK, DataFrame, it's on 2.0. There is some things committed, not fully. I think there is some things still open. I have not seen that backported in any other release. So if you want to test this one, you have to get the Apache version. Is anyone familiar with DataFrame? Just you? Two of you? OK. Me a bit also. DataFrame is a way to describe tables and data by abstracting the underneath layer. So here is an example. I want to map an HBase table, but I want to have an abstraction from my HBase table. So I will define a table, and then I will give parameters to say, look, my column 0, basically in HBase, it's a column qualifier, it's my row key. My column 1 in HBase is my column qualifier 1 and column 1, and type is Boolean. So I give types, and I give a mapping between my HBase table and my DataFrame declaration. So if you are not used to that, you will find that very useful. But I will skip this one if no one is aware of that. It's a way to read and write in a table based on an RDD. So I have an RDD, which is data, and I will do that as a data frame. I will map it to my catalog. I will want 5 new regions, and I will just save my RDD into my table. So you just write that, and you have a data RDD going into an HBase table without doing anything else. Same thing on the other side. This one is to read. OK, and that's the one I want to show you. So you remember I mapped few names, column 0, column 1, into my HBase columns and column qualifiers. When I do that, I will filter my HBase table. I will get an RDD back with all those filters applied into my RDD. And you don't have to write any line of code. It's just you put syntax like equal or different or lower than, greater than, and that's all. And the same way here, which is very similar to the one before, same thing. I have my catalog, the first line, and I can do SQL on top of that. So this will do Spark SQL on top of your HBase table. Just one caveat here. We can do it. It doesn't mean it's efficient. It doesn't mean it's the right way to do it, okay? SQL on HBase is cool, but here there is no coprocessor, there is no things behind the scene which will help you to be more efficient. If your primary use case is SQL on top of HBase, maybe you don't want to go that way. If your primary use case is random access a lot, and sometimes you want to help with 1 or 2 SQL requests, then go with that. Else, you might want to choose other products on top of HBase or maybe just something different.
So it's basically in this case, it will just read everything into memory and do whatever it does with all the optimizer in memory.
So the question is,
there will not be any push downs or anything of that kind.
yes, the question is, basically here it's going to load everything in memory and do a full table scan, and the response is, I don't know. I hope not. I have not built that part. Normally, we don't do that. Usually, we have some push-down logic into the region servers to avoid. We have filters, so we will use the filters. It depends what it is. Here, you go on a column, so you might have to read everything. If you have something based on the row key, then we might be able to use filters.
But essentially, this notation is absolutely the same as the notation with data frames in previous slides.
Yep, it is.
It's kind of whatever is your answer, I don't know, to this one applies to the previous one as well.
Yes.
Maybe there is also everything what we just read.
Yes, this one and the next one are really similar, I think, behind the scene on the logic. It's just different notations. But honestly, if it reads everything, I think it will not read everything forever because at some point it will be optimized. Phoenix has done a nice job on that. They have a lot of filters. So when you do something like this on Phoenix, they will look at the key and then we put filters. And so they will read only some part of the regions. And I guess Refodian and the Splice machine might be doing exactly the same thing also. So all those tools are already doing push-down filters to not have to read everything. And I will be very surprised if Spark just goes the dumb way and read everything. So that's something to be tested. Only on 2.0, so I have not get a chance to test it a lot, but something to test more. So this was the demo I planned to do initially, but I have 5 minutes left, so sorry about that. The demo has been chopped. I did a small demo, which was a producer to Kafka, to Spark streaming, to HBase, to Solar. If you want to do that, it's about maybe 10 lines of code, maybe 20. Producer was like a Twitter, generating tweets where I have the sentences and the words, and then I put that into Kafka for queuing. Spark streaming consuming that, feeding HBase to put all the words and to have counters, and all the tweets as sentences, and all of that indexed into Solar. I will make the demo available for who want to have it, because you will see it's very, very simple. It works very well. I built that with not the 2.0. I had to use the CDH 5.8 because I was looking for a specific mutation method, which was not there on other versions. But I'm sorry, we don't have time for this one. If you have questions on this demo, just talk to me after, and I will be very happy to send you a link or whatever. So it works well. And that's all. So we have 4 minutes for the questions, if there is any. Yes, on the back.
So, what was the answer in terms of the table scan? I didn't follow that.
The answer in terms of the table scan, so for the that one?
Yeah.
The answer is I don't know, because we should do filters. We should have push-down filters into the region servers to not do a full table scan. But it depends what is your request. If your request is to do a select distinct on something, I have to read all the keys, all the values. So it will be a full table scan. If your request is a select with a where clause and the where is a row key, then I can be smart and I can go to the right region and read just small part of it. So it really depends on what is the request you will do and the current state of the implementation. So this one is a 2.0. It's not fully ready. It's not yet released. So it's more like a beta. So it's very difficult for me to say, yes, for now it's a full table scan, but maybe when we will release that in a few months, it will not be a full scan anymore.
Thank you.
Any other question? No? Okay, thanks a lot.
doing this? Yeah, sure.
Two microphones.
Okay, no problem. I'll just hand you this.
Thank you.
All right, thank you very much. All right, so we have the last two sessions of the day. So in here we have big data with Sangjin and I always butcher Scandinavian names, I'm sorry. Joep, thank you. Talking about Twitter timeline service with HBase. And in the other room, Alexio is giving a presentation in Bakerfield. Give it to you guys.
Okay, thank you. I'd like to make one small correction. This is not Twitter's timeline service. This is actually Hadoop Yarn open source timeline service. That's fine. Yeah, because timeline is very familiar term with Twitter. So we're going to talk about the Hadoop's Yarn timeline service version 2. I'd just like to see a show of hands. How many of you are familiar with timeline service in Hadoop? Okay, about several, okay. So let me talk about what that is first. Okay, I don't have a slide for that, but so timeline service is basically a way of storing many kinds of data, metrics, configuration, and things like that into a storage coming from Hadoop clusters or Yarn clusters so that we can use that data to do useful things. So we call that timeline service. One good analogy would be, if you're familiar with MapReduce, you might be familiar with MapReduce's job history server. So if you go to a job history server, you can take a look at it. You can actually drill down into all the configuration, tasks, mappers and reducers, and counters, and all the fun things about your MapReduce applications. So timeline service is really an extension or a generalization of something like a job history server so that it actually covers not only MapReduce, but basically any type of framework that runs on top of Yarn. So that's the first motivation. And also second goal is really to kind of unify the view between a live application as well as completed application. If you look at job history server, that's strictly for completed applications, right? But if you are interested in finding out the same thing about a running application, what you do is actually you go to the RM UI, you drill down into it, and you actually go to the application master UI. But timeline service is really sort of trying to unify those things into two dimensions. One is between MapReduce and more general type of frameworks. And the second dimension is unifying things between running applications as well as completed applications. So it's really trying to cover all four elements in the matrix. So why is it important? Why is something like that important? And we can think of many reasons why this can be important. And there are three things I can think of at least. The first thing is basically just imagine your applications like Hive or your Scalding or your PickJob. Usually they launch multiple Yarn applications. They do all kinds of very complex things. And you usually want to sort of visualize them in a kind of a waterfall type of visualization. And there's very rich data sitting there, but the basic Yarn UI doesn't really do justice to that type of data. So basically, the timeline service can really unlock the visibility into this rich data that users actually have there. So that's why it's very important. And the second thing is you can also build tools like chargeback. If you're running a multi-tenant cluster, then you want to be able to attribute a certain cost to certain users. User A used, say, 10% of the clusters during this time frame. User B used, say, 50% of your cluster cost. You want to be able to sort of attribute it back to the right users, and you can build tools like chargeback and whatnot. And a third interesting use case is actually something like finding a problem node. You earlier heard the talk from the Facebook person that if a node is being very, very slow, sometimes it takes a lot of manual effort to find them, right? But with something like timeline service, what you can do is basically you can quickly see which node is losing, for example, speculative execution. You can easily build tools like that. So if node B is consistently losing speculative execution throughout some hour period, then you know that there's something definitely up with that node. And you can quickly mark that node down or blacklist it in that manner and take it out of circulation. And then you can actually have a much healthier cluster and things like that. So node level visibility, kind of analytical visibility into a complex stack of jobs, and also being able to build like historical trending. All these things become possible with data coming from timeline service. So it's basically an enabler feature that we have in Yarn. Let me go talk to a little bit about the history of timeline service. Back. So Yarn actually built a version 1 of timeline service a while ago. And it gained some amount of adoption with like test community and the Hive community and whatnot. And it kept improving the performance and scalability of the timeline service. But it is still facing some fundamental challenges. And they can be described in two major things. One is basically scalability and reliability challenges. So timeline service v1 actually uses level DB as a backend storage. And as such, you basically had a single instance storage, and you can easily imagine why that's not going to be able to serve any decent sized cluster. Because the moment you fill up that single node, then you're done. So that wasn't really very scalable in that sense. And also you had a single instance of the timeline reader and writer through which all reads and writes go through. And that actually became a really big sort of scalability bottleneck because you're at the mercy of that single node really scaling. So this really didn't really scale beyond a few node cluster type of thing. So we quickly realized that something has to be solved there. And that's actually where HBase comes in. And the second thing is about the usability. We really wanted to build a timeline service based on the notion of a flow. And I touched upon things like Hive or Pig or Scalding and things like that. Woozy is another good example. Users don't really think about individual Yarn applications as their unit of work. They usually think of their Scalding applications or their Hive queries and their Pig and things like that. They usually spawn multiple jobs, sometimes some of them even concurrently. So you really want to have an understanding at that level, which is really a higher level than individual Yarn applications. And we wanted to model that as a Yarn flow. And we actually are surfacing that in the timeline service next generation. So to quickly summarize the difference between V1 and V2. Instead of a single reader-writer, we moved to a distributed writer architecture. Moving from a single local level DB storage, we are using an HBase, much more scalable storage there. And we have an enhanced entity model that's using the notion of a flow. We also provide a certain amount of automated metrics aggregation so that if your individual Yarn applications have certain metric values, we actually automatically aggregate them up to a flow level, so you don't have to do that math yourself. So that's actually provided out of the box. We also provide a fairly rich set of REST API. Just for historical background, all this is actually based on Twitter's previous open source project called HRaven. We actually have this thing called HRaven that actually uses HBase as a backend, and it accomplishes a lot of these things. But it was actually still focused on the MapReduce, but we are kind of expanding it to handle all kinds of different frameworks with the timeline service v2. It's basically, this is really rehashing the architecture. So this is the architecture at a very high level with a single Yarn application.